With all the things we've discussed with Steve Terry and myself during this presentation, something's come up. We've had consultants and dealers and end users all come to us saying, all right, all this information about LEDs is great, but how do we deal with designing our systems? So we don't really have a crystal ball and we didn't really have the magic answers, but we got together with some of our friends and did some research and maybe came up with a direction that we could use. So the bottom line here is that one of our salespeople goes into an engineer's office and they say, hey, I'm trying to design a theater and I need the most effective system you can do for initial cost. Next day he goes into another theater and that person says, I need the best artistic capabilities you can give me. And on the third day he goes in and says, I need the lowest operating cost. How do we get all these and still maintain the artistic qualities and the value that the customers need when we're developing systems? And what about combinations? What about people that need high artistic and low cost? Well, we started this process and we tried to figure out what to do. And basically we looked at lumens, we looked at number of fixtures, we looked at number of circuits. And there are so many variables when you talk about theatrical systems, we were having a hard time figuring out what to start. And at one point we said, well, what do we know really well? And what have we done? In the project management group, we have a saying that says, well, our typical job is the $150,000 high school. So we started by looking at the $150,000 high school and did a bunch of research on that. So what did we do? We mined 5,000 systems in our business system and looked at the data from there. But we realized that all the data wasn't coming directly from our business system, that some of our dealers were selling equipment and some of the equipment was used or leftover equipment they had in the facility. So we surveyed the dealers and the reps and the end users to find out what equipment was actually being used in these facilities to get a true picture of the equipment in that facility. We also needed to find out installation cost. How much does it cost to install equipment? So we called contractors. How much does it cost per foot to do an installation? We got an average from across the country and spent a good deal of time on the phone dealing with that information. The bottom line is that we've been doing this for a long time, and the system has really been very similar throughout all these years. So the assumptions made were that the lumens are right, the flexibility of the system is right, and the coverage is right. So maybe we could take that technology and that system and apply it to some of these new technologies that are coming down. So here are assumptions we made to make this program go forward. One is that this is a high school theater. This is your typical high school, going down market, going up market. Any other market may not apply to this model. This is your typical high school, okay? In your typical high school, theatrical lights are on for about 2 hours a day. To help figure lumens and figure power wattage, we assumed that these fixtures were on at full the entire time. Now we all know that that's not true, but when you start to look at the variables, okay, well the front light's on at this level and the back light's on at this level, it really becomes an impossible task to predict the power. So at 2 hours a day, the fixtures are on at full. That's applied as a constant throughout, so it evens itself out. The calculations we use for lumens are based on field lumens. Beam lumens would have been more accurate, but a lot of the comparative fixtures that we use didn't publish those beam lumens, so we had to use field lumens to keep apples to apples. Also, we used the 575 watt long life lamp for our incandescent fixtures. It is not the brightest incandescent lamp out there, but is the one that most of you buy most often. So we want to be true to what's out there in the field. When I calculated power costs, we used 17 cents per kilowatt hour. That's not accurate in Montana. It is accurate on most of the East Coast and a large portion of the country. So again, we plugged it in as a constant and we've used it as a constant. As we talk money, we're dealing with factory list pricing. So this is the pricing that an end user would expect to pay for this equipment as we go forward. As we calculate installation costs, we looked at the length and we figured that the average length of a circuit in a high school is about 100 foot. Some are going to be shorter, some are going to be longer, but the average is about 100 foot. Again, this is plugged in a constant and it's used across all systems. I mentioned that we talked to some installation contractors, and what they determined is that the cost is about $2.50 per foot installed of a theatrical circuit, okay? Now, that's a whole bunch of data thrown at you, and that's a whole bunch of constants that we're assuming. Some of you are saying, you know what, I don't believe some of those, I think you're full of it. Well, that's true, I may be. But at the end of this presentation, we have a table, and we're going to be able to manipulate that data to plug in some of your data to see if it works better for you in that way. So, what did we find? This is the actual research plot that we found in your typical high school. Now remember, this is an average of all these systems that we looked at, and that this system doesn't actually physically exist. However, when we looked at the systems that were out there and the products that they had, this is virtually what we found. What we're looking at here is a system where there's approximately 4 electrics, a couple of catwalks. We have a straight-on Broadway front light wash, and we have some downlight back light washes that are double hung to provide us some blending and toning with different colors. We also have a high side light wash that's used to illuminate a dance show or to give fill. So this is pretty typical for what we would find. There's also a cyc wash here in the background to help illuminate our cyclorama. Make sense so far? So let's look at the infrastructure of what that system is. To support that, we have an ion console and 192 circuits coming out of sensor dimmer cabinets. As we look at the stage electrics, we'll notice that there's a whole bunch of circuits out there. This is truly a dimmer per circuit system where there are dimmers and circuits everywhere in the facility, allowing very good flexibility. The flexibility is important in theatrical spaces as we design systems and want to be able to change our lights from show to show. We also have a data infrastructure there, which is supported by our equipment rack. DMX distribution over network was common in what we're finding in systems today, so we've utilized that as well. As you look at this graph where you see the pink dots, that represents a gateway or a signal translator giving us DMX at that location. The blue points represent the data output or a network jack for us to plug in some portable type equipment. So let's look at some specific statistics on this facility. We're looking at 192 dimmers in this facility. Total lumens without the cyc is 478,000 lumens, okay? The daily operating costs, with all those assumptions given in the beginning, are about $22 a day for those 2 hours on. Current drawn 190 amps, and theatrical costs are $141,000. So when we joked about that $150,000 sweet spot, we're really kind of right in the game. Installation costs on top of that were another $48,000. So now we're in the world of LEDs, and we've talked about what LEDs can do and where they're coming from and what they can do for us, and everyone's all excited about it. All the things we previously talked about in this presentation. So how does that plug into this technology? What do we need to do to make that plot work? So we took some people and we sat down and we started to draw a plot that was a full LED plot, keeping the same infrastructure of the theater that we'd done all the research on. What we found is that we switched to a LED cyc wash in the back. We went with a color-changing LED downlight wash to give us blending and toning. We kept our high side lights, but look at the front wash. Notice the front wash, we had to double hang that front wash. Why? Because the lumen output of the LED fixtures wasn't a close enough match to what we were doing with the incandescent fixtures to give us enough illumination on the front. So we did have to make some modifications to make this work, but virtually we kept the same plot style and the same format, just replaced all the LED fixtures. Here's where things start to get a little crazy. We looked at what the infrastructure needed to support all these solid state fixtures were. The interesting note is all the equipment on the left-hand side of this graph are exactly the same. The ion console remains, the unison control system for house lights remains, the equipment rack remains. The major change here is that we've replaced the sensor dimmers with echo relay cabinets. So we are now on 100% switch power in this facility, and we've gone from 192 circuits down to 48, okay? But one careful note to make, look at the electrical distribution. While we've reduced the number of circuits, we haven't reduced the number of outputs significantly. So I still have the flexibility with my theater to plug in fixtures anywhere that I need, okay? The data infrastructure has remained the same across the facilities. So let's look at the specs of what we found. In our all-LED theater, we're looking at 48 circuits. We have approximately 86 fixtures. We were able to reduce a couple because of the double-hung backwash that we had for the incandescent theater. But look at the lumen output. The lumen output has dropped significantly. We're now looking at about 290,000 lumens compared to 478,000. That represents a pretty significant drop. You also notice that the power has dropped significantly. We're looking at $5.76 a day. That's an incredible power savings. But also realize there's not as much light there. So somewhere in the middle, if we match lumen for lumen, we're going to be using more electricity to match those lumens. Okay? But look at the cost. The cost here is the huge difference. We're looking at about $275,000 for the installation of this system, plus $12,000 for the contractor work on top of that. So cost becomes an issue here in terms of dealing with what's your budget. So people go back and forth with us and say, why should I be using LEDs at this point? You know, they don't seem as bright, they are more expensive. What are the advantages? As a guy that was a designer once, I just get excited about the color capabilities that I can do with LEDs. As we look at this chart, we'll notice that the front column represents an LED fixture matched to a specific gel color. In the case of the one on the left, that's gel number 64. So to match that color, I needed to change the emitter output of some of those LED fixtures. Notice an incandescent fixture behind that, gelled to number 64, has less lumen output than that fixture. So as you look down this row, we'll see that in the saturated colors, the advantage really goes to LED. But why do we like incandescent fixtures? Well, when we're talking about the non-saturated colors, the colors that provide the blending and the toning and the facial illumination, those colors right now are better served by incandescent fixtures. We've done a similar thing with the graph here where we have gelled the incandescent fixtures and color matched it to the LED fixtures. And you'll notice the LED fixtures shown in the front of this graph have far less output than their incandescent counterparts in the back. So it kind of seems to me that there's a good balance between what LED can do and what incandescent can do. So that led us to think, what if we did a hybrid plot where we let the LEDs do what they were good for and we use the incandescents doing what they're good for? And that's where we came up with the layers of light plot. So in this plot, you'll notice we've taken the LED cyc light and left that in. We've taken the side lights and made those incandescent fixtures. The blending and toning top wash, we've made those LED fixtures to give us the color control that we need. But we've replaced the front wash again with the incandescent fixtures to give us the punch that we need to illuminate the people on stage. So one thing to note about all of this is that these fixtures that we're utilizing here have the source 4 dimmer attached to our incandescent fixture. So let's talk about a transition that we're making here. As we look at this slide, we'll see that the infrastructure for the layers of light theater is identical to the infrastructure for the LED theater. This is building us a transition. As the LED fixtures get better, we have built the infrastructure into this facility. As we talked about before, putting wires in the wall is expensive, and we want to get it right for the long haul. This is giving us a transitional path from now into the future. So what this system relies on is dimming control at the fixture. We're able to use the same circuit utilization that we have for the LED theater, but by putting the dimmer at the fixture utilizing the source 4 dimmer, we can now have a fixture plugged in at any point across the facility. So we have infinite flexibility of plugging any fixture into any circuit in this building and making it work to our desire. So let's look at this layer light theater. Circuit-wise, we're coming in about 48 circuits. We have fewer fixtures here because we were able to reduce some of the washes. We got the fixtures doing the most efficient thing that they're best at. Look at the lumen output. The lumen output is very close to what we were doing all incandescent. Operating costs, right in the middle, kind of what we would expect. And the max current draw, about the same too, kind of in the middle where we would expect. And look at the equipment costs. The equipment cost is coming in, you know, kind of in the middle, but not super high as an LED system, with the installation cost, again, matching that of the LED system because it's the same system. So we did some math, and we had a little bit of fun with this. And one of the things that people are talking about is lumens per watt. You hear that all the time. How many lumens per watt do I get? How efficient is my fixture? A number that we found kind of maybe more useful than that is what's your lumens per dollar, right? So we took a look at how much does it cost to get 1,000 lumens of light. So with an incandescent theater, it's your best option. I can do that for $11.86. With the layers of light, it costs me about $41. And if I want to go LED, it's up there about $83. get that cost down. How about total costs? This is what really matters to everybody. Where do systems numbers break down? Well, if we look at the incandescent theater, when you consider installation, we're looking at about $189,000. Layers of light is right in there at $195,000. But look at LED. That jumps up to $287,000 when you consider installation costs. And again, just for fun, because we like to play around a little bit, we said, all right, how many LED fixtures do I have to install, and how much is that going to cost to match the lumen output of my hybrid theater? The installed cost of that system is $385,000. So that kind of starts to build a little picture here that an all-LED theater, if I need to match lumen per lumen, right now is still a little out of touch. So where are we? You know, you look at the curve of incandescent development, and over 90 years, we went from the bunch light to the radial bunch light to the first LECO light, and then some of the older fixtures, and now the source 4. If we look at the LED curve, we go from the bunch light to the radial bunch light to the first profile fixtures, all the way to the source 4 LED. Look at the difference in time span. Over that time span, we've come a long way, and the technology is going to continue to grow. So the question is, do I invest now? I think the answer is yes, you invest now. The reason is that you want the technology, the artists want that technology, and it's time to get in. Do you get in full bore? Do you do everything right now? Do you replace all your fixtures with LED? I think a balanced approach is really the way to go, and I think dollar for dollar, we've shown that it's a good way to approach it. A nice hybrid layers of light theater will get you there in the future. So, I told you earlier that we'd be able to play with the data. We'll take some questions from the audience, and what we'll be able to do is we'll be able to manipulate the data. If you think I was incorrect in some of my calculations, we'll go ahead and change those live for you now and have some fun with the numbers. Thanks very much for your attention.